As we get ready to study derivatives, one thing that we'll need to be able to do is evaluate functions. And although we've done this before, I would like to give you a little bit of a refresher first. So at the end of this lesson, you'll be able to evaluate a function given certain values in its domain. All right, first of all, before we go into evaluating functions, I just want to make sure that we remember what a function is. Pretty much everything that we use in calculus is generally a function. The formal definition of function is just a relation between x and y that has the property that any two ordered pairs with the same x value also have the same y value. So as an example, just up here, let's see. If I have 2, 6 on my graph, 2, -6 or 2, 7 could not be points on the graph because then that would not be a function. So if there is x is the 2 value, the only y value that's possible is just 6 or whatever I pick it to be. Right? The independent variable of the function we generally refer to as x. That's the one where we can plug in anything that we want. And then the dependent variable we generally call y, and that's called dependent because the answer for y depends on what we plug in for x. Right? A convenient way to test whether a relation is a function or not is by looking at the vertical line test. And just a couple examples of this. Let's say I have this relation right here, and I want to decide if it's a function or not. If I draw some vertical lines through the relation or through the graph, we're just going to look at where the vertical lines touch. Notice this vertical line touches one spot. This touches in one spot. This vertical line touches in one spot. This line touches in one spot. Notice I really couldn't draw a vertical line that doesn't touch in more than one spot. Yes. So this is a function because a vertical line passes through no more than one time. And basically what's that testing for is there's only one point with a certain x value. One that would not be a function, let's say if I had a sideways parabola, and notice I can just draw one vertical line and I already notice it doesn't work. The vertical line passes through more than one time, which kind of is showing, like as an example, this might be the point 3, 2, and this is the point 3, -2, and that's not allowed. If I have an x value, they both have to have the same y value, and they don't in that case. So that does not pass the vertical line test. So this one was not a function, and this one was. All right, now let's start to evaluate a function. And just in case you don't remember, pretty much we're just going to plug in the given value for the independent variable and simplify. So in this first example, we have f of x equals the square root of x plus 3. And when it says to find f of 6, all we need to do is go into our function and we'll plug in 6 for the x value. So we'll put 6 plus 3. That gives me the square root of 9. Which is 3. So we have just found that f of 6 is equal to 3. All right, a little bit harder example here. Let's say we have the function x cubed minus x, and this time it asks us to find f of x minus f of 1 all over x minus 1. So I'm going to deal with f of x first, and it tells me that f of x equals x cubed minus x, so that's what I'm going to write down first. And then minus, the next thing that it tells me to do is to find f of 1. So wherever I see an x, I'm going to put a 1. And then it's going to be all divided by x minus 1. Okay, next thing that I'm going to do is go ahead and evaluate what's inside of the parentheses. If I have 1 cubed minus 1, that would just equal 0. And then I don't really have to have minus 0, so I'm just going to get rid of that. And then I notice I could be done, but I do notice some things can happen, and we want to always have our answers as simplified as we can. So I notice in the numerator I could factor out an x, so that's exactly what I'm going to do. And when I factor it out, I'll have x times the quantity x squared minus 1. It's still all over x minus 1. And then I do notice that I have a difference of squares, so I get to keep going. Lucky me. All right, so this is going to factor as x plus 1 times x minus 1 all over x minus 1, and now we hit the bonus because now I can cancel the x minus 1 in the denominator with the x minus 1 in the numerator since we have all factors up there, and I will be left with x times the quantity x plus 1. So that will be my simplified answer to evaluating that expression. So now you should be able to evaluate functions at a certain point.